Hello and welcome to this new tutorial. In this tutorial, we are going to simulate the circulation of water in the tank and we will make an animation at the end. So let's start with the space claim and I start with drawing a circle with the diameter of 1000 millimeter and then I pull it for 1500 millimeter. Uh, In order to make it like an egg-shaped tank, I click on the edge of this circle and then drag it inside for 500 millimeter. The next step is to make some inlet and outlet for uh, this tank. Let's just make some planes on X and Y. So if you click on the first plane and then make your sketch mode plane view, I'm going to make some sketches. All right, 50, 100, 100. Okay, this is going to be the sketch for the inlet on both sides actually that I'm going to pull, uh, and I would like to have three of them. Therefore, I will just copy and paste it and then move it. All right, let's see. So if you click on this surface and Control C and Control V, you can have another surface and then just click on the surface and then move it and then drag it for 250 millimeter. Now you have two of them. So if I repeat this process, Control C, Control V, and then click on the third surface and then move it for another 250. All right. Now you have three surfaces that I'm going to pull on both sides. These are going to be by inlets, okay? So let's unclick the solid and then you have three surfaces, right? Which I'm going to pull. Select the pull, select the surfaces and then go on pull, right click, pull both sides, okay? So because you want to pull them on both sides and then go for 1300. Now you can have activate the solid. Let's delete the planes, we don't need them anymore. And basically you can combine the solids. Now you have one solid which is looking really good. The next step is to give this inlet some angles because you don't want to inject the water like 90 degrees. I would like to give it some angle. Therefore, I go to select, use box, or let me do it again. Use box. Now all the faces are selected and then I go to move and I would like to rotate it around this y-axis for let's say 55 degrees, or actually not 55 but 50. Okay, and now you can see that the water is going to be injected on this direction and then it's going to circulate that way. Therefore I have to repeat the same for the other side. Let's go to design or select using box. Uh, Repeat the same process. I'm going to rotate it this way for 50 degrees, or was it 55 or 50? I think it was 55. No, it was 50. Okay. All right. This looks good. These are going to be my 6 inlets, and then I need an outlet at the bottom. Let's go to sketch mode, then uh, all right, circle 150, and then I am going to pull it out. Make sure that you click on add and drag it for 600. All right, this is going to be your geometry with 6 inlets and 1 outlet at the bottom. All right, let's mesh this. Double click on mesh. The first thing I'm going to do is to do some name selection. Give the name of inlets and outlets. Still opening up. All right, this is inlet 1. If you click on N on your keyboards, the name selection will be inlet 3. Then the other side, inlet 4, 5, 6, and then this is going to be outlet. Okay, the first thing then I'm going to do is to add some inflation. Select your body, and then basically I'm going to use all the faces for the boundary except the inlet and outlet. Okay, so then click on this and then Control A, and then use the control to deselect these boundaries or surfaces. Okay, I'm deselecting the inlets and outlets, and then click apply. Now you can see that 28 faces are selected. Let's just mesh and see what we basically get. Okay, go to mesh and then click on update. All right, this is quite coarse. Let's go to mesh and then sizing. So you can see that the element size is zero point 0.1. You can decrease it to 0.5. Then click on update again. Okay, now it looks much better, and you can also see the inflation. I can make a section plane as well to make sure that I have the inflation inside the tank as well on the wall side. All right, this looks good. We can just be happy with this. This is not the finest mesh, but I think we can live with it. So let's just close this. All right, the next step is setting up the simulation. Double click, double precision. I would like to use 20 solver processes, and then click on start. So I'm going to speed up a little bit. We are already 10 minutes into tutorial. Uh, the mesh is loading. I'm going to pause the recording, and once the loading is done, I'm coming back. Okay, now the mesh is loaded. This looks good, and you can make it like polyhedra if you like. This is done. The next thing I'm going to do is actually I'm going to change the fluid from air to water. Go to Fluent database, and then the water liquid is almost at the bottom, and you just copy it. Okay, and then you just close it, and then the next thing you have to do is to go to cell zone condition, double click, and change it from air to water liquid. Click apply. The model I'm going to use is for the viscous term is a standard K omega model, SST. Actually, I'm not going to use a standard, but SST. This is going to be the default for the K omega. I click on OK. The next thing that I'm going to change is the boundary condition, and for the inlets, I'm going to use the shift and then right click and multi-edit. Let's give it the velocity of 0.3 meter per second. Click on apply. The valves are valves. The outlets, the only outlet we have is at gauge pressure 0, which is fine. I'm not going to change that. The methods for the simulation and solution is coupled for the scheme of pressure velocity coupling, and the rest is default. I'm not going to change them either. But we need to initialize it first. Let's initialize hybrid initialization. All right, the initialization has not reached the convergence tolerance, but it's fine. I think I forgot one thing, and that is the gravity. 9.81. I would like to run a transient simulation, and then I think I have to do the initialization again. Let's do the hybrid initialization. All right. The error is a little bit lower, but still has not reached, but that's also fine. I would like to make a movie animation for the circulation. Let's start with this, making some surface, a plane on X or ZX plane. Okay, so let's make it 75. I call it ZX1. And then I'm going to make another one, plane ZX2, ZX plane, and then I'm going to move it to the first one, first inlet. You see, I'm going to intersect it with the first inlet. I think 1.27 is good. That's perfect. Now we have two planes on ZX plane. The next thing I'm going to do is to make a contour for these two planes. Right click, new, velocity magnitude, ZX1, save and display. And then I call it contour. I think velocity 1, save and display. And then I'm going to repeat this for the second one, velocity magnitude, contour, vel 2, save and display. And then I'm going to make a scene. Or basically, let's make a mesh, new. I'm going to show you only the edges. Okay. Display state, manage display state. I'm going to make a new one, isometric, and apply. And then this is going to be isometric. All right. And then the last step is to make a scene, a new one, and then select mesh 1, contour velocity 1, and contour velocity 2, and the display state is ISO. Save and display. This looks perfect, except that I forgot to change these ranges. So from 0 to 1.5 is too much because the velocity is only 0.3. I think 1.5 is quite a lot, so I'm going to change it to from 0 to 35 maximum meter per second. Save and display. And also for contour velocity 1, yeah, from 0 to 0.35, save and display. And now you can clearly see this is perfect. And then go back to your scene and save and display. Look perfect. All right, and then I would like to make an animation. For that, you click on calculation activity, solution animations, and then you make sure that you record your scene 1 for every time steps, okay? And you click on OK, and you have animation 1, which is going to record your contour plot of velocity, basically this scene, for every time step. Let's just run the simulation. I think time step 1 is okay. If you like, you can make it smaller, 0.5, and then the number of steps to, I think, 200. Then reporting intervals, I think I will report it every 20 iterations. All right, let's calculate it. And you can see already that the velocity contour plot is developing inside the tank. I'm going to stop it, and then once the simulation is done, I'll come back with the final results. All right, the simulation is done, the calculation complete. I click on OK, and if I go to scene 1, you can see the scene that we created together. The flow is almost fully developed inside the tank. If you want to look at the animation, I go to animation under results and then double click on playback, and then you can decrease the replay speed a little bit. Then you can see how beautiful the flow is circulating inside the tank until it gets fully developed. If you like to save this animation, you can change it to video file and then click on write, and then the video will be saved. I can also show you a vector plot. If I go to velocity and color by velocity and show it on one of these planes and click on Y, basically I'm going to change this auto range again. I'm not very happy with this auto ranging. You can clearly see the circulation of water in the tank in a clockwise manner. All right, this was the tutorial for the circulation of water in a egg-shaped tank. I hope you have enjoyed it. Until next time.